We are Group 6. Our presentation will be over autonomous trucks. Group members are Colin Hemingway, James Alessandro, Reese Dunlop, and Matt Vajai. Supply chain structure will involve players, power, sequence, and complexity. There are three main players in the autonomous truck industry that are making the biggest movements: Mercedes, Freightliner, and Otto. Here's an example of one of Freightliner's fully autonomous trucks. As you can see, the interior of this is more modern, with easily readable touchscreen monitors for the driver if there is one present. Freightliner's automated trucks come pre-installed with 7 hidden, conveniently placed sensors that monitor the outside environment. A key player in the autonomous truck industry is Otto, who recently has been bought by Uber. Otto makes equipment that makes existing trucks automated and costs around $30,000. Otto has already made a couple Budweiser deliveries of over 120 miles in Colorado. Next is driver power. Drivers know that they can get a job anywhere right now and are becoming extremely picky with the loads they want. Self-driving trucks can pick up that slack and the slack that Intermodal is currently trying to get. This will decrease the driver shortage. The demand for goods keeps going up, but the supply of drivers keeps going down. Autonomous trucks have the ability to replace over 1.7 million truck driving jobs, but that is very unlikely. Autonomous trucks will save money in many areas such as fuel consumption, safety, and the driver demand. The number of traffic jams and accidents will decrease dramatically. We will bring this up later on. On this infograph, you can see the different stages of automation. We are currently in the driver assist stage, where emergency braking systems, adaptive cruise control, lane keep assist, and driver assisted truck platooning. It's hard to say how long it will really take until fully automated trucks will become uncommon on the roads. Critics say it could be between 5 and 10 years. The complexity comes in with the vast network of Internet of Things that you will need to have to run your operations, such as connecting the trucks. This is an example of a new concept called platooning. Platooning will save money on fuel because they will be drafting off each other and will improve safety trucks communication. Several states are already laying groundwork for a future with fewer truckers. In September, the Michigan State Senate approved a law allowing trucks to drive autonomously in platoons, where 2 or more big rigs drive together and synchronize their movements. That bill follows law passed in California, Florida, Utah, that set regulations for testing truck platoons. Getting people on board is the hard thing. Missouri has already outlawed the testing of platooning.
A significant infrastructure funding increase is needed to make autonomous technology safe and reliable because deficient infrastructure such as potholes and poor lane markings can impede autonomous truck movement. The federal government must take a leadership role in autonomous technology deployment in order to prevent local and state governments from creating disparities that limit commerce and obstruct the successful adaptation of these potentially safe and productivity-boosting technologies. The Department of U.S. Transportation has made a commitment to push autonomous vehicle research with a 10-year, $4 billion investment to accelerate the development and adaptation of safe vehicle automation through real-world pilot projects. Although growth is expected overall between now and 2020, there is no stable environment coming for the global commercial vehicle market. The truck industry, and especially its original equipment manufacturers, will therefore have to negotiate a tricky balancing act. They will need to be prudent when entering new obligations and at the same time prepare themselves to grasp appropriate market opportunities as they present themselves. Most important, they should focus on emerging markets, which are expected to drive global sales growth. Increased fuel efficiency and lower maintenance costs from more optimized truck operations due to autonomous guidance systems alongside improved safety performance will round out the gains fleets should get from so-called driverless trucks.
Talk about risks for autonomous trucks. Accidents are a big problem in today's world of trucking. One of the reasons for implementing driverless trucks is to reduce the human error of the truck drivers. However, it is very hard for artificial intelligence of autonomous trucks to predict the human driver or what the human driver is going to do. Another issue with the technology was if a truck could maintain its lane if it were to blow a tire or have an equipment failure. One of the biggest obstacles to autonomous driving will be teaching the artificial intelligence systems to understand how human drivers think. That has presented a problem for Google's self-driving program. Its autonomous vehicles have involved in nearly 20 crashes over the last 6 years. All but one were blamed on the human driver. But the Google prototypes may have contributed to some of the obeying laws in which the human drivers don't. At stoplights, for example, the vehicles have been taught to immediately stop if the light turns yellow. Yet in many situations, such as heavy traffic in urban regions, motorists will often make a left turn at the last moment. Expecting the Google cars to do the same, they've rammed the prototypes on a number of occasions. Currently, the world of trucking is experiencing a driver shortage. Autonomous trucks could help combat this problem. Also, this would not necessarily put drivers out of work. Drivers would still be needed in situations where they have to navigate crowded cities and docking of the trucks. Current technologies can also not handle bad weather, so there would be a driver needed to handle these situations. The problem moving forward in autonomous truck driving will be regulation. The question is, are people really ready for driverless trucks? The technology may be there, however the regulation may not. It is hard to tell what the structures of the laws will look like in the coming years. Another risk for autonomous truck driving is going to be security. Carriers are going to have to worry about hackers breaching their networks to manage these trucks. They're also going to have to worry about hackers deactivating key sensors and GPS features so that they can lead the trucks to an undisclosed area and potentially rob them of the goods and possibly the truck.
Now on to scale requirements. Significant initial investment is required. As the safety and reliability of the autonomous software increases and the price point decreases, the production will grow. This table represents the annual economic savings of implementation at different market penetration percents. For example, at the 10% market penetration level, congestion savings represent 66% of benefits, and crash savings represent 21% of benefits. Compared to at the 90% penetration rate, 33% and 58% of the benefits are included. When comprehensive crash costs are included, overall crash savings jump by more than a factor of 3. Next, we move to scale requirements. As market penetration of autonomous trucks gradually increase, key requirements will emerge. First, we have road infrastructure. The autonomous network is being developed using the existing roadway infrastructure. But as the implementation occurs, experts believe that the number of vehicles on the road will skyrocket, causing more needed investment to be made to roadways. This can have a positive effect on the movement of the vehicles and reduce traffic congestion, allowing for a decreased uncertainty pertaining to the actual traveling of a shipment. Decreased uncertainty of freight movement leads to carriers embracing large capacity supply chains. However, this can also have a negative impact concerning fuel emissions from the increased truck volumes. This will further push the development of renewable zero-emission fuel sources. Secondly, we move to labor unions. A large amount of drivers will lose their jobs, causing labor unions and other job protection movements to resist the mass implementation. However, due to the increased capacity networks, human workers will still be needed for loading and unloading of shipments. Third, we move to competing industries. Freight railroad industry is restricting autonomous trucking because road movement will become as direct as the railroad industry. Accident liability. A framework for autonomous trucking liability is absent, creating uncertainty in the event of a crash. Security concerns should be examined from a regulatory standpoint to protect the traveling public. One key issue relates to how the vehicle is programmed to react to random obstacles and how to distinguish them. For example, if the vehicle is approaching a cardboard box versus a concrete cinder block in the middle of the road, the question of how to teach these computers to decide whether to hit the object or to avoid it makes the general public skeptical to the safety of driverless trucks. Also, autonomous truck platoons may cause problems for human drivers entering and exiting the highways. Lastly, we move to network security. Cyber hackers may target the software used on autonomous trucks, causing mass collisions and disruptions. One infected autonomous unit can quickly lead to the entire fleet of units being infected. The National Institute of Standards and Technology is currently developing a framework to improve critical infrastructure cybersecurity. Sustainability. There are key points to keeping autonomous trucks moving in the future. First is the safety of R&D testing. Public perception of autonomous trucks can change quickly with one deadly accident. These vehicles will be held to a higher standard than human drivers. If public perception turns negative, this can delay the mass implementation significantly, leading to higher development costs. Next, we have funding for research and development. State DOTs, local transportation agencies, and planning organizations could also help fund such research to enable regions and nations to anticipate and more effectively plan for opportunities and impacts. Uniform regulations. The DOT needs to further assist R&D efforts and develop a framework with a set of national guidelines. Policymakers should also consider potential regulatory downsides and effects of excessive caution. Next, we have liability standards. The liability standards will need to strike the balance between assigning responsibility to manufacturers and technologists without putting undue pressure on their product. Lastly, we have data privacy. Robust cybersecurity to address the vulnerability of these systems will help the industry develop ways to prevent outside attacks. These vehicles will inevitably cross state boundaries. Federal regulation needs to establish parameters regarding what types of AV data should be shared with and whom it should be shared with, and in what way the data will be made available, and what ends up being used with that data.